Welcome. This is the ASP.NET Core Deep Dive. We're going to be diving deep into ASP.NET Core today. Hopefully you already have some familiarity with the new stack. It is new, and this is kind of a fun deep dive for me to get to do, because I think this is my first deep dive since we have shipped version 1.0. ASP.NET Core is now version 1.0, and I don't know about you, but personally I think that's pretty awesome. We have .NET Core now on Windows, Mac, and Linux with a completely new HTTP request pipeline. We support self-hosted scenarios, hosted in IIS, hosted behind Nginx on Apache. Red Hat is supporting .NET. I mean, that is just amazing. I don't know if I ever thought that I would see that happen during my career here at Microsoft. So this is great. This is a chance to go a little bit deeper than I think we've at least I've had a chance to go in the past with one of these talks. So hopefully you have some familiarity. If you don't worry about it. You all look like advanced people, so I think you'll be able to handle it. It'll be great. It'll be fun. We'll be looking at a lot of different things. I picked these topics to dive a little deeper into today. We're going to take a look at ASP.NET Core hosting. We'll look at the hosting model in ASP.NET Core, like what it means to actually get ASP.NET Core up and running, start listening for requests. We'll also look at a little bit about what it means to host it in production, like how does it work when you host it on Windows behind IIS. What are the patterns that we recommend for using when you're hosting in production? Just a little bit on production hosting, not a lot. We'll be focusing more on the stack and on the features. Already a question? Yes, yes.
Are you going to be talking at all about the differences between running it on full .NET versus .NET Core?
Not a lot. I'm going to be doing all my demos on top of .NET Core today. I'm not going to be doing any full desktop demos versus .NET Core demos. We'll leave that for a .NET Core talk. This is really going to focus on the ASP.NET Core libraries themselves and what they're capable of, how they work. So we'll be looking at the server, the request pipeline, how request handling works. We'll look at some of the middleware in the stack specifically. We'll take a deep look at routing, how routing is set up and how it functions, and how that interplays with MVC, ASP.NET Core MVC. And then we'll take a deep look into MVC and look at some of the really cool extensibility features that MVC offers that I don't think we've spoken a lot about, but they're pretty powerful and enable a lot of really cool scenarios. So that's what we'll look at. We'll try to kind of build from the bottom up. We'll start from bootstrapping the system, through getting a request, through getting into routing and routing it someplace and executing some code, all up until getting to MVC and actually extending what MVC is capable of. So that's the goal. Hopefully you already know how to get started with ASP.NET Core. So if you don't, well, go get the bits now and start reading the docs and catch up, because we're going to move kind of fast through this stuff. There's lots of sample code, wonderful docs on the doc site. But basically, just go to .NET and download the bits and install them. You can do that on your Mac as well as on your Windows machine. So let's start talking about hosting. Like, how do you get an ASP.NET Core app up and running? One of the really interesting things about ASP.NET Core, and that really is different from ASP.NET in the past, is that ASP.NET Core really is just a bunch of libraries. It doesn't have any host process that comes with it. You provide the host process pretty much in almost all situations. If you're writing a .NET Core application, most of the time that host process will be .NET.exe. That's the process that will actually boot up the CLR, start running managed code, and then get into the ASP.NET Core hosting logic. If you're running on the full desktop CLR, like on Windows, well then there's Windows magic that will allow your exe to boot the CLR and then call into code. But ASP.NET Core itself is just a bunch of libraries. It's not like with ASP.NET where you had was it WebEngine 4 or whatever that would bootstrap CLR and get everything up and running in IIS. This is a different model. Pretty much everything is self-hosted. That gives you a lot of flexibility. You can host in a console app. You can host in a Windows service. You can host in an NT service. You can host pretty much wherever you'd like. This is what the hosting process looks like. There's two high-level steps. You need to build a host. There's a web host builder that you use to do that. What that will do is you'll set up the host services, or at least the web host builder will do a lot of it for you. You'll configure which server you want to use. Most of the time, you'll probably be using Kestrel. That's our new managed HP server that we ship with ASP.NET Core. It's blazingly fast. It's cross-platform. You can run it on Windows, Mac, and Linux. The construction of the host will identify your startup logic, like the logic that really defines what your app is. You'll say what that startup logic is and where you want the host to locate it. And then build will actually then build your app. And what it will actually build is this thing called a request delegate. And the request delegate is the thing that every request will get handed to, and that will then execute the logic of your application. So you build your host, and then you run the host. And when you run the host, that will actually start the server, tell the server to start listening for requests. And every time it receives a request, it will then hand that request off to the request delegate, which is your application, and responses go out, and away you're off and running. There are a bunch of interesting configuration properties that you can fiddle with when you're setting up an ASP.NET Core host. You can specify what server you want to use. We provide you Kestrel. You could write your own if you'd like to, for those of you who write HP servers on your weekends. We have another server that we've been working on for a little while, and we do plan to ship. There's a web listener server that is basically just built very tightly on top of HP sys. That's the same underpinnings as IIS, so that's a Windows-only server, but there are good reasons to support that server as well. Or you could write, you could write a custom server. You can specify the server URLs that you want to listen on. You can specify what your startup logic is. We'll show that. There are these two interesting concepts of paths in the system that you should be aware of. One is the content root. The content root is the path where all your app stuff is located, like your MVC views are relative to the content root. The web root is where typically all of your static files get served from, and that is also relative to the content root. By default, the web root of your application will be www root, and that'll be relative to whatever the content root is. By default, the content root will be the location of your app's assembly. It's basically the same as I think it's application-based path is what it's called in .NET. By default, it equates to that concept. But you can change it to be something different. And sometimes that's convenient. In fact, our templates typically do change the content root to be wherever you're currently running from. Because often that's your project folder, and that's often where a lot of the files are that you want to discover. There's the environment. There's a first-class notion of environment in ASP.NET Core. Like, are you running in development, in production, in staging, or whatever other environments you want to define? That gets set up at the hosting layer. And then there's also an application name notion. I don't actually know of any use of the application name other than as a friendly name for the app, but you can specify it. You can specify it in the host. So let's take a look at what all this stuff is. And we're going to start from scratch. Let's start from scratch. Let's not do this folder. Let's make a new directory, VS Live Demo. All right. And I'm going to start from the command line. I hope by now that doesn't scare anyone. This is not to say that you have to do everything from the command line in just a text editor. You can go into Visual Studio and create new templates and all that. Wonderful tooling is all there. My goal here is to start as simple as possible and introduce concepts. So, but some people like working this way. If you really love Vim and just a command prompt, then this will really appeal to you. So let's create a new .NET Core app. Everything I'm going to do today is .NET Core based. And to do that, I use the .NET command line interface, and I'm going to say .NET new. And what did that do? Well, that gave me just these two files, program.cs and project.json. To open those up, I am going to use my favorite simple text editor, which is Visual Studio Code. It's really nice. It does a lot of really great stuff. And it has some nice C# extensions for doing .NET development. All right, so it opened up the directory with those two files, and it's already prompting me to say that there are unresolved dependencies in my project.json file. What does that mean? Well, the project.json file is what specifies what all the dependencies are for my app. And in the .NET Core world, that means NuGet packages. Like, what packages does this app need? And it's telling me that you need to restore those packages so that they're available for development. I'm going to go ahead and tell it, well, I'm not actually going to tell Visual Studio Code to do it. I'll show you just from the command line. .NET restore is what I need to do to restore those packages. And you'll notice that as soon as that's done, another file has popped up here on the left-hand side And I see some people squinting. Let me see if I can make it a little bigger. How about that? So this file is capturing the entire resolved dependency graph of all the libraries that your app depends on. When you specify them in your project.json file, you only need to specify the top level ones. Now this project.json file, it says I don't have any app-specific dependencies. It does say that this is a .NET Core application, and it's using the Microsoft .NET Core app package. What is that? That's the what we affectionately call the shared framework. It's a set of the BCL libraries that pretty much every app needs, and that you can expect to already be installed on the machine. You install .NET Core on the machine so that you can then run your portable .NET Core apps on that machine by doing .NET, whatever the app is. Okay? So I've restored the application, program CS. That looks like hello world, nothing fancy there. Let's run this app, .NET run. That's what we do there. And this will do two things. You can see the output actually did succeed, hello world. That actually did two things. It did a .NET build to actually build the application, and you can do that separately if you'd like, just like I just did. And then it ran the built assembly. If I just open up a file explorer and look at what's now in this directory, there's now a bin and OBJ folder. If I go digging into bin, there's the output from the build. There's the actual DLL. To run that guy, I can now just say .NET and then the name of the assembly, and that will just run the app. So that's the normal application model for running .NET Core-based applications. You say .NET and whatever the DLLs that you want to run that has the entry point. It's very similar if you've done anything with Mono, like you do Mono, whatever you want to run, or Java, or Python, or a lot of these other, anything that's pretty much cross-platform will have this model. So, yeah?
Do you have a pre-built Docker images that are available for running this in Docker?
There are pre-built Docker images available that already have .NET Core installed that you can just go and grab and use, and they're on the Docker Hub, so you can just go grab those. All right, well, that was just the intro to .NET Core stuff. Let's actually do some ASP.NET Core stuff now. So I'm going to go into my project.json file, and I'm going to add what it basically amounts to the core of ASP.NET Core. So Microsoft.ASP.NET Core. What do I want? I want server. Let me get some nice IntelliSense here. It's kind of cool. And so I'm adding the Kestrel package. This is the Kestrel HP server. You only need to specify the top level dependencies. Everything in that's required by the Kestrel server will get pulled in, including the ASP.NET Core hosting libraries. So that's all I need. Save that. I'm going to go ahead and restore from Visual Studio Code just for convenience. And it said it completed. Great. So now I have that package. So now what we're going to do is wire up ASP.NET Core hosting. So to do that, I need to build a host. Remember, right? Build a host, run it. So to build a host, I use a web host builder. And Visual Studio Code's, come on. I believe in you. Yes. Sometimes Visual Studio Code's namespace resolution stuff gets cranky. All right, so I'm going to use a web host builder. And I'm going to tell it I would like to use Kestrel as my server. And then I'm just going to define actually my app inline right here. I'm going to add a configure method to configure the request handling pipeline for my app. And it's just going to be hello world for right now. So we're going to find a little delegate here that says all I want my app to do is to run this little piece of logic, which is take the context and write hello world to the response. Right async. Hello, VS Live. All right, I got some namespaces I'm sure I need to resolve. Yep, the builder namespace and then the HTTP namespace. Good. Okay, that should all have been red squiggly list. Oh, I got one more here. Oh, that's because I need to actually build it. So there, I built my host now. And then the second step is to run it. Okay, so there's about 10 lines of code. That is a ASP.NET Core app server that returns hello world. Let's go ahead and actually run it. So .NET run. So that started the server, and it's telling me it's now listening on port 5000. Let me open up an impartial third-party browser. And hello, VS Live, okay? Now, normally, you don't define your app startup logic inline on the web host builder. So what we're going to do is now going to follow the standard pattern, which is we define a startup class. So I'm going to create a startup.cs file that will contain the startup logic for this app. And we should be good and have a namespace. I think it's console application. That's what they do by default. And let's create a startup class. So instead of having that configure method just sitting directly in the web host builder, I'm going to define it here, public void configure. And it's going to take that application builder object that you saw previously, application builder. There we go. I think I need to resolve a namespace. Yeah. All right, and then so I'm going to now just move the startup logic there. Okay, so now this is going to be my app. Oh, I've got some more namespaces I got to re-resolve. Let's do that quick. Is that everything? No red squigglies? Looks good. So I can now remove this configure and just instead say use startup. And I'm going to give it the startup class that I just defined and say that's where my app is actually defined, is in this startup class. And then we'll find the configure method on that guy and call it. And just to make sure that we know that we've done something different, let's add a little more excitement. Woo! Okay, now let's shut this down and run it again. Okay, it said it worked, and I should see a whole bunch more excitement. There we go, okay? So that's just how you get hosting wired up. Was there a quick question?
Why does startup not implement an interface?
It does, actually. There is an iStartup interface that you can use. When you use this convention pattern, we actually dummy up an iStartup implementation around your startup class and then use our conventions. You can do it either way. Like you can define your startup logic using the delegate. You can say, go look for an iStartup implementation in this assembly. Typically, we use this convention pattern, though, where you just define a class that follows the method patterns. That's just the way our templates are normally done. But there is actually an interface that's underneath it all. All right, cool. So let's take a little bit more look at hosting and the properties that are available. So remember I said there's a bunch of properties that you can define. Like for example, if you want to specify which URLs you want to use, that's what you would do here. So use URLs, or if you wanted to specify the environment, use environment, that's right here. You could say this is development, or this is staging, or whatever. And that will then permeate throughout the system, and things can pivot on which environment you're currently sitting in. The environment also normally just gets specified using an environment variable. So specifying it statically here is will be a little bit odd, but you can do it if you wanted to. You can specify the content route. These are all just extension methods off of the web host builder, all those properties that you saw previously. All right. So there's also a use server. And you can specify an iServer implementation right here that you'd like to do. That sounds like fun. So I want to talk a little bit about what it means to implement a server, because I think it's kind of interesting. So I'm going to create a public class myServer. I'm just going to implement iServer. And are you going to get to resolve that namespace? No, I think it's in the server there. OK, great. And what does this guy look like? And how does it work? I want to implement namespaces, implement my interface. Yeah. All right, cool. So a server just has a couple things on it. First of all, it has a features collection. Now, what is that? Well, features are interfaces that express server functionality. Like there's a server feature for a way to get the addresses that the server is currently listening on. And this is just a collection of stuff that the system can query to get, what does the server currently support. I'm not going to implement any particular features for my very simple server. You have to have dispose logic. I'm just going to leave this empty for now. The real interesting method is start. This is what the web host, what the host will call when you tell it to run. It will start the server and tell it to start listening for requests. So how does this actually work? So in here someplace, normally you would listen for requests, right? And you open a socket and listen for HTTP or whatever. But then high level, what will happen is you take this application object that's getting passed in, and you're going to tell it to process the request. You'll notify the app, hey, I've got a new request. And you'll give it this context object of some type, which actually is being dictated by the application. OK, so how do we get a context object, and what is it? Well, there's also a nice helper method on application that's create context. And create context, you'll notice, also takes a feature collection. And because the way that requests in ASP.NET Core are really represented are as these collections of feature interfaces. Let me show you what I mean. So let's create one. So we need some features. Let's create some features. I happen to know that there is a feature collection type that we can build up. Do I already have the names? Oh, new. Okay. Okay, and we can add things to it. So features dot set. There's an interface IHTTP request feature. And I happen to know there's like a stub implementation that I can just put in here. IHTTP request feature. And I'd love to F12 on that. So I think what I'm going to do actually right now is I'm going to move out of Visual Studio Code and go into Visual Studio so we can see what is going on there. So open project. And this is a nice little trick if you don't know this, that you can just point Visual Studio, and I'm doing demo, at the project.json file, and it will just open it up and dummy up a MS Build file for you and all that jazz. Okay, so where were we at? We were in Program CS. All right, so we're creating a feature collection for this request, and there are two features that every server has to provide for every single request. One is the IHTTP request feature, and let's take a look at what that guy is. Nothing too surprising. It has a body, it has the headers, it has stuff about the method and the path. So the server has to provide that information for each request that comes in. There's also a IHTTP response feature. New HTTP response feature. Okay, and this guy has pretty much what you would expect. It has the status code of the response, the description, all that jazz, and headers. Now, around these feature interfaces is what ASP.NET Core will then basically shrink wrap in a context object. You know HTTP context. HTTP context is normally how you interact with the request and response in both ASP.NET and in ASP.NET Core. In ASP.NET Core, that HTTP context object is really just sort of like a facade, like a pleasant way of interacting with these feature interfaces. And it sort of just looks to see, okay, where's the IHTTP request feature? Okay, there it is. Where's the IHTTP response feature? And there may be feature interfaces that aren't provided, and that's fine. The context object just won't give you access to that functionality. So for example, maybe my server doesn't support, maybe it does support WebSockets. There's a feature for IHTTP, was it WebSocket? Yeah, WebSocket feature. I can choose to expose that for the request or not. The server maybe doesn't support that. And that's how those two parts of the system interact. Okay, so those are feature interfaces. And there's a whole bunch of them, like for session state is a feature. The static file middleware, the thing that actually serves up JSON, JavaScript files and CSS files and whatnot, it will look for a iSendFile feature, which is a Windows-specific way of serving up static files to clients. That's really, really fast. And if it's there, the static file middleware will use it. If it's not there, then it will do a way that will work, but maybe it's not quite as fast. So that's how this part of the stack works. All right. So I'm not actually going to fully implement my server. I had thought it wouldn't it be great if I could do like an in-memory server, like on the fly, on stage. That would be so hardcore. It turned out that I don't actually have to because there's already one that exists, and we ship it. So if you go and grab this NuGet package, it's a cool little package that's called a test host package. Let's grab that guy. Where is it? ASP.NET Core test host. You guys see that? So I'm just going to install that guy. Yes, I accept the license. All right, there, the restore completed. And well, what do we need? What was the? I need to have a few little compilation errors. I'll just make sure it go away. Okay, now what I'm going to do, I'm just going to let's just comment out this code for now. And I'm going to use this this in-memory test host server. What is this guy? So I'm actually going to create a client, but first we will create a server. So we're going to create this test server, and the goal of this test server is to be able to run the whole pipeline in memory. So that if you wanted to do things like an end-to-end integration test, you can do that with ASP.NET Core. So let me resolve the namespace here. There it is. Okay, so this is a little bit flipped than what you just saw previously, where you created the web host builder and then you configured the server on the web host builder. In this case, I'm actually going to give the web host builder to the test server, and it will take care of calling build and calling run for me. I don't have to do that, but I do have to give it the web host builder that I want to use for my app. So new web host builder, and I think I just need to say use startup, because it will also set up the iServer implementation that this guy creates. And that's it. Okay, and then I'm going to call what this test. Where do the requests come from? Well, the way this test server works is it gives you an HTTP client, and every time you call, get or send over some sort of request with the HTTP client, it signals that path to say there's a new request. Pump it up the pipeline, and then it comes back down again. So that's how this part of the test server is implemented that way. Basically, it says if the HTTP client sent a request, then do this stuff. That's how that all works. Okay, so create client, and then let's do var text equals client.get string async. Then we're going to make a request to localhost. That's what the test server always listens on, just localhost. There's no port, because it's not actually listening on the network. And then I'm going to do a dirty little thing, and I'm going to do .result here. Don't ever do .result in real production code. But I'm going to do it here because it's a demo. And then let's just write out the results. Text. I think that's it. Okay, so I'm not using that my server stuff. That was just to show you how everything works. But I'm now using this little in-memory test server, and just to make sure we're all believing that it's doing something different from test. How about that? And let's run it. And there it is. See, it ran that. If you don't believe me, it's actually running the whole pipeline. Let's just set a breakpoint right here. So it's actually calling into this little chunk of request handling logic. And let's run it under the debugger. HTTP client sends a request. Boom, hits your middleware. Continue F5, and everything. Where'd it go? Everything just shuts down because I didn't put a read line at the end of the app. So that's how servers work in the hosting layer. And like I said, we do plan to provide a web listener, an HTTP set-space implementation soon. That's in the works. Cool. I think that's it for hosting. I do want to talk a little bit about hosting in production. Like that was just like, how do you get the app up and running? How does ASP.NET Core handle bootstrapping the app? But what if you actually, I want to host, an IS or in real life. Actually, I could have my app out there. How do you do that? One important thing with ASP.NET Core is we do recommend that you run it behind some sort of reverse proxy, a mature server that can handle internet-facing web traffic. Kestrel is great. It's fast. There's a lot of good work has gone into it already, but it is a new web server, and we're very cognizant of that. And so our current guidance is we don't recommend putting Kestrel directly on the internet. There's a lot of nasty HTTP requests out there, and we're not sure yet that Kestrel can handle all of them without putting your app at risk. So while we do the security hardening, our current guidance is that you should have some sort of proxy server sitting in front, whether that's IIS when you're running on Windows, which is the normal recommended configuration. If you're running on Linux, it could be Nginx, it could be Apache, it could be HAProxy, or whatever you'd like. But there should be something there. So this is the pattern that we generally recommend. You have the mean, nasty internet sending who knows what to your application, some sort of reverse proxy, and then that then forwards the requests to your ASP.NET Core process, like Kestrel. So that's generally how we want things set up. How does that look when you're dealing with IIS? With IIS, we ship a new native module that's called the ASP.NET Core module. And what this module does is it receives requests through IIS, and then it just forwards them to a process of your choosing, some exe that you tell it to start and hand the request off to whenever it receives the request. And that's all it does. It's just a forwarder. It does have a bunch of other features that it supports. It supports like forwarding client credentials. It supports Windows authentication, IIS sub-applications. It has a nice feature where you can take the app offline by just dropping an app_offline.html file. That's nice so that when you deploy, you don't get locked file problems. It has a nice logging model where it can log everything that exe that it started is spewing out to standard out. That's what we generally use when you're hosting behind IIS. To set it up, you do that in web.config. So in your web.config file, you need to specify that the module should be there and specify what process it should start. For .NET Core apps, that's going to be .NET.exe. For full desktop applications, that will be whatever your app exe, the actual Windows exe that you built for your application. You can set up that web.config manually, or we have a tool actually that can help you. Now this tool does something incredibly simple and sets unbelievably high expectations. The tool is called IIS Publish tool, the IIS Publish tool. And when people see this tool and they say, oh, run this, and suddenly everything's going to be running on IIS. That's not actually what it does. All it really does is it will create this web.config file for you when your application gets published in the .NET Core sense. During development with a .NET Core application, all the NuGet packages, all the binaries that it needs to run typically are just sitting somewhere in your user profile in a common directory where you've restored all of the packages that all your apps on your machine need. And that's just for development. When you actually need to go publish the app, like move it someplace so it can run on a server, you need to collect all that stuff up, all the assemblies that your app needs, and put them in one spot so you can then copy it over to IIS or wherever you're going to be running the application from. That's what the publish step is. You do a .NET publish. And as part of that step, this IIS Publish tool can be wired in and create the web.config for you and make sure that the right executable and the right arguments are specified so that the right app runs. Okay? So that's what the IIS Publish tool is. It's not going to create the app for you on IIS. It's not going to actually move the files anywhere. It doesn't do any of that. It's just creating this web.config file and configuring it correctly. And then lastly, in your app, you do need to receive the requests that are coming from IIS. And there's a bit of a handshake that happens between the ASP.NET Core module and your app in order for that to successfully occur. So you need to enable IIS integration in your host. And there's a call that you do, webhostbuilder.use IIS integration. And that will set that up. And I'll talk a little bit more about exactly what happens there. High level with the ASP.NET Core module, this is what occurs. IIS will receive the request. Then I'm going to use ACM just for short for the ASP.NET Core module. ACM will basically will receive any request, like any request on any path, any verb, and it will then start the app in a separate process. And at this point, your app it's not running in W3 WP.exe. It's typically .NET.exe or your full desktop exe that will be running. ACM will then forward the request to your app. Your app processes the request, sends back the response to ACM, and then ACM sends it back out through IIS. That's the high-level flow. The most brittle part of this flow, where people most run into issues, is the starting of the app in a separate process. When ACM actually goes and tries to run whatever it is you told it to run, if anything blows up in your exe, like for whatever reasons it doesn't start up, then it kind of just dies, and then you're left scratching your head like, what happened? And that's when you need to go do things like look in the event log and try and figure out why the exe didn't actually start. And one simple trick is just go try to start the exe directly as opposed through IIS. It's a common gotcha. This is what the config file looks like. So as you can see there, it's adding the ASP.NET Core module as a handler. It says path star, verb star, so it'll basically handle any request that comes in. And then the configuration below says which process you want it to start and what arguments you want handed to that process. So the process path, in this case, .NET.exe, and then the arguments, the name of the DLL that you're running. Question?
Within IIS, I know IIS will restart the app pool every now and then. Will it do anything like that to recycle this external process?
I believe it's still going to manage this process like you would expect an IIS app to be done. It's not like if this process goes down, it will restart it and get it up and running again. So we'll do things like that. There's also some logging options here where you can capture standard out from the executable that ran and just dump it to a file. So that special handshake that occurs between the ASP.NET Core module and your process is really driven by these 3 environment variables that the ASP.NET Core module will set up for you. It will set up the port and then the application path that you want to use. That's so it knows where to send the request to. And then it will also set up an environment variable with a token. And what is that token for? That's a pairing token so that so that your app can know that the request actually came from IIS and not from someplace else. That you didn't some other random request to localhost and just somehow end up on your process. So the ASP.NET Core module will set up these environment variables, and then the process needs to read them, make sure that there's a listener actually at that path and port, and that it validates that that token is actually set up. And that's what that use IIS integration piece of code on the web host builder will do. So let's take a look at that. So I have a simple little ASP.NET Core app here. Sure, let's save the solution file. That sounds fine. And what this app is going to do is it's just, again, it's pretty much just hello world still, but it will capture a few extra things and display them for each request. So here's that run method again. You know, we get a request in. What do we want to do? So I'm just setting that the content type is going to be text plain, just so Edge and IE will happily run their text. It's getting, you can see here, a server feature. Remember we talked about server features? So servers expose collections of features. One of the features one of the features that is available is the addresses that the server is currently listening on. So I'm asking for the server features, and specifically the iServer addresses feature, so I can figure out, well, what addresses is this process currently listening on? And then I just write those out to the response. Then second thing I do is I'm going to read in those environment variables that get set by the ASP.NET Core module. And I'm doing that using the configuration system. If you don't know about the new configuration system in ASP.NET Core, it's really nice, really lightweight way of reading in name-value pairs from a whole variety of sources, including environment variables. So I'm just going to use that logic. So using the config system, I read in these three environment variables, the ASP.NET Core port, application path, and token environment variables, and I just display them. So if I run this app, I'm going to switch it to run as just as a console app, like no IIS involved at all. You'll notice that the address that I sent the request to and the address that it's listening on, exactly the same. And there's no information about environment variables because they're not there. There's no, they weren't set. This is just I ran the console app, and that's all that happened. Okay, let me close that down. If I instead run this behind, in this case, IIS Express, which is a good analogy for IIS, now you'll see that the request that this process is actually listening on is not the same as where the request was actually sent. This is where IIS is listening. This is where Kestrel is listening in that .NET.exe process. And then here are those three environment variables that got specified. There's the port, there's the path. That's what we're listening on. We took care of that for you. And then here's that token, that pairing token, so we can know that the requests are actually coming from IIS. Now, the magic that sets that all up is, first of all, there is a package. If we look at the references, there's this IIS integration package that you do need. And that's what will give you for your web host builder that use IIS integration call. And that call will look for those environment variables, make sure that a server URL is added for the specified port and path. And it will also make sure that no requests make it through that don't have that pairing token. Okay? If we look in web.config, this is that's what we expect. There's the ASP.NET Core module. It's all wired up. There's some placeholders in VS for the process path and arguments so that VS can manage those. But when we publish, those get substituted with the correct values for whatever type of app it is that we're going to be running. That substitution will happen thanks to the IIS publish tool. If I go look in project.json, in the tool section, there's the IIS publish tool being added. It's just added as a NuGet package to your project. These are project level tools that we're talking about. And then on post publish, there's a post publish script that gets added to run that publish IIS tool to tell it where to put the output and which framework it should be dealing with when it updates the web.config file. So that's how that all works. So if I actually go and publish this guy, publish. Let's do a new one. 32, sure. All right, we're going to publish the file system just to make it easy. And let's create a new directory on my desktop, I guess. Let's do ISPub 3. Did practice this a little bit. All right, and yeah, that looks fine. So publish. So that's now collecting all the binaries that are needed for this app to run. And then after that general publish step is done, it will run that post-publish script to run the ISPublish tool to create the right web.config file in the published app. So let's go take a look. Is it there? Publish 3. And if we look in here, there's the web.config file. And if we look at it now, let's, where's VS Code? Open my VS Code. Now you'll see that the process path and the arguments are actually specified. So if you have no web.config file at all, it will just create one for you, this ISPublish tool. If you do have one, it'll update the arguments so that they're correct. And that's how hosting in IIS works. Okay, we're going to move up the stack now to actual request handling. So now we're going to get into your app, where you've now got that request. It came in from the server. You called that, that notification to the app to say, I've got a new request. Here's a bunch of feature interfaces. Gets shrink wrapped in a context object that's now available for your app. So your request handling pipeline gets defined in startup in that configure method, and it's defined using middleware. You use middleware to process requests. Your entire app will then get built into a single request delegate that encapsulates all the middleware that you said you wanted to use. And we provide you lots of built-in middleware that you can play around with. We have routing middleware, authentication middleware, static file middleware, diagnostics. You can read the rest of the list. There's a whole bunch of stuff that you can use. And that request delegate's kind of interesting. Let's take a look at it. This is the request delegate. It's pretty simple. It's just something that takes the HTTP context and does something with it asynchronously. So the whole stack is async, takes the HTTP context, does something with it asynchronously. That's how your whole app is modeled in the system. This guy just gets called with any request that comes in. Middleware is a little bit more mind-bending. Middleware is something that takes a request delegate. And that request delegate that it takes is like a next pointer to the next middleware. And then it returns a request delegate with whatever it is that the middleware wants to do. And inside that request delegate that it returns, it could choose to call the next pointer, like it could call the next guy. It could do something before it called the next guy. It could do something after it called the next guy. It could choose to not call the next guy at all and just return something. That's kind of like what you've been seeing me do for most of these demos, where I just say run, return something to the response stream. I don't care about any other middleware. I'm not calling next. You can do that as well. You could throw an exception. You get a 500. And that's possible. This pattern of an inline func isn't normally what you write when you write middleware, although you can, and it's kind of fun to do it. We'll do it together as a test. This is the normal pattern that you use to write middleware, which is a convention where you write a class, and the constructor of the class takes the input request delegate, the next pointer, gets injected into your constructor by convention. And then you can also have additional parameters that get injected into your constructor that, through dependency injection, through the DI system. And then the request delegate that your middleware returns is implemented by the invoke method. And the invoke method, as you can see, what does it do? Takes an HTTP context and does something asynchronously with it. That looks like a request delegate. By convention, we'll look for that invoke method and say, that must be the request delegate that this middleware is defining. So the next pointer goes in the constructor, and then invoke is what you actually want to do. And in that invoke method, that's when you can call next if you want. You can do something before, after, or not do anything with it at all. When you use this pattern, there's an extension method you use to add your middleware. It's the use middleware extension method, use middleware of T, where T is your middleware type. And it's considered a kindness, a best practice to provide your own extension method, like use MVC, use router, use whatever the name is of your component that you're defining, that basically just calls use middleware of T under the covers. And that's how all of our middleware in ASP.NET Core are implemented. And when you configure all your middleware, this is what you end up with. It's a pipeline. Request comes in. The first middleware is the outermost middleware in the stack. It can run some stuff, calls next. Next middleware runs some stuff, calls next. And then it all just finds its way back out. So it's kind of a wrapping model. The first middleware is the outermost in the chain. All right, so let's look at defining middleware and messing around with request delegates. And what does that look like? I think I'm going to file a new project on this one. Start from scratch. OK, this is the middleware test. All right. Empty. Looks good. All right, let's see if we can write some middleware. Let's do it, and we're going to try to do it the inline way, because I think it kind of helps to get the frame of mind of what middleware really is. So here I'm in the configure method of my startup class, and this is kind of like, sugar for middleware, but that doesn't call next. This is just run, and here's my request delegate. I don't care about next. And that's not what we want to do. We want to actually do some real middleware, and you use middleware. So I'm going to say app.use. This is where I now need to provide that delegate. It takes the request delegate that's next, and then returns a request delegate that does whatever it is the middleware does. So I need to take the request delegate. So let's define a next parameter that takes the request delegate, and we're going to do something with it. Well, what are we going to do? Well, we need to return the request delegate that defines this middleware. A request delegate is something that takes a context object and does something with it, right? OK, so what are we going to do? I want to write a piece of middleware that just is going to add a response header, just some random custom response header. So I'm going to do context.response.headers. Sorry. Let's do VS Live header. And let's make it equal to woot. OK? And then we still need to return something. This is a request delegate. It has to return a task. We want to still run the rest of the middleware pipeline, right? So we should call next. Well, I've got the next pointer right there. So next. And you do have to hand it the context so that the next middleware can do something. And boom. And that should be it. Did I do it right? Get it all done? There's no squigglies. That's a good sign. Let's run it. OK, hello world. So we actually we hit the ladder middleware, but do we have the response header? Let's see. F5. Let's look down here in the response headers, and do you see it? VS Live woot. I wish I could zoom. I don't know that thing you zoom in, but it's there. It's there. So that worked. OK. Whew. Wow. It was a lambda inside a lambda. We're 2 lambdas deep. It's like Inception, right? It's a dream inside a dream. Yes. OK. So that's a bit of a mind-bending way to implement middleware, but at least if you can do it, then you probably understand how it works. There are some other sugars that can make it a little bit easier. There's one that there's a variant where instead of taking the request delegate, it just gives you the context and the next pointer, where the next pointer isn't really the full request delegate for the next guy. It's sort of a wrapper around it where we've already taken care of giving the next guy the HTTP context, so you don't have to. So it's just a func of task that represents next. And you can just assume that it will get the HTTP context somehow. So that's another way you could do it. So it looks like this. So you only have 1 lambda in this model. It's not quite as fun. But context.whatever. And then you can just call it next. And that would just work. OK? And then run is the even simplest form, where there's no involvement of the next pointer at all. OK. But what if we actually want to write a real middleware that we're going to ship as a binary and share with our friends, and we want to support dependency injection and all those things? How do we do that? Let me show you an example of what that would look like. And there was a question while I opened up this project. Go ahead.
So in that example where you added the response header, you're adding the response header as the request is coming in, right? What if I wanted to add something as right before the response was leaving? Would I just await next and then
do stuff after? Yeah. So you would say this would have to be async, right? And then like it's a wait. Is that right? And then do stuff there. Yeah, that's what that would look like. So you can do it before or after, and you have complete control of that. You just do whatever flow meets your scenario. OK, I was going to open a project. Let's do some real examples. So this is a sample actually that you can find in the entropy repo on in the ASP.NET org on GitHub. Here we have a couple of custom middlewares. There's a XHTTP header override middleware. What this middleware is trying to do is, based off of a header or a query string parameter, it's trying to swap out the HTTP verb of the request. So you send a, I don't know, like a GET request, but then you put a header in the request that says, server, please treat this as if it's a post, or treat it as if it's a patch or a delete or whatever. That's what this first middleware is trying to do. And the second one is just trying to return a response. It's kind of like the hello world middleware we've already done, but it takes a parameter to control what it's going to return in the response. Let's look at that one first. So we're going to look at the my middleware. So remember the pattern. You have a middleware type. It has a constructor that takes the next pointer. So there's the request delegate coming in through the constructor. And then there's other stuff that can be injected in the constructor. The first group of stuff that can be injected are parameters that got specified when you set up the middleware. So if we go back up here to that use middleware call, you notice there's a yo at the end as the greeting parameter. That will get added, injected into the constructor as the first batch of parameters. Anything after that is then just DI, like whatever services are available in the DI system, okay? So in this case, we have both. Like we have the greeting coming in from that use middleware call, and then we also have a service from DI. And then all this guy does, you can notice that it doesn't actually do anything with next. It holds on to the pointer, but all it does is send the greeting, greeting response, and then it also says what it thinks the HTTP verb is, okay? Now the other middleware, that XHTTP header override middleware, this guy takes the next pointer and it actually uses it. So it will look for either the header or the query string parameter, and if it's there, then it changes the method of the request. If it was a GET request, it becomes whatever the value of that header was. And then it does call next and just lets the pipeline flow. So what I would expect to happen here then is that when I run this app, I will see the output of the yo middleware, but I should have the ability to change the verb that appears from the yo middleware output, if that makes sense. Okay, so let's run it. Okay, so this was a GET request, obviously, right? It was a browser. It sent a GET request. And yep, there's the greeting that got specified. The yo middleware is working. And it thinks that request was a GET. If I now specify, I'm not going to use the header because it's a little harder to specify the header. I'll just use the query string. I did delete before. Let's do, what's your favorite verb? Options? Is options your favorite verb? And now it thinks it's an option. So that middleware is running, swapping out the method so that the next middleware in the pipeline thinks that this is now an options request. So that's how you implement your own custom middleware. Okay, but we provide a bunch of good middleware for you. You don't have to implement your own. One of my favorites is routing. Routing middleware is something that's supposed to take in requests and funnel them off to interesting pieces of code to handle those requests. And it is actually the basis for how MVC works in ASP.NET Core. MVC doesn't really have its own middleware. It just sits on top of routing, of a generic routing middleware. And you can too. Here's how routing works. There is a routing middleware, and it is surprisingly simple. It does almost nothing. Like all it does is it takes an iRouter. An iRouter just has like a route async method on it or something like that. It takes a context object. It just calls into that router and says, route, and here's a context object. And when the route logic is done, if the context contains a set request delegate, what to do next, then the routing middleware says, oh, OK, the request was handled, and it executes that request delegate. If it doesn't find a request delegate, then it just calls the next middleware in the pipeline. And that's all the routing middleware does. It's incredible. It's like 5 lines of code. I'll show it to you. But there's a bunch of other interesting components in the routing system that add more power. So first of all, there's also a route collection. So there's an iRouter implementation that is just a collection of routes. And all the route collection iRouter does is it will iterate through each iRouter and ask it, can you route this request? And then it checks the request delegate. Is there a request delegate? Yep. Then it's done. If not, then it calls the next iRouter in the collection. And if it doesn't find any, then it doesn't set the request delegate at all, and you go to the next middleware. So it's just iterate through until you find an iRouter in your collection that handled the request. Good, then you're done. That's what route collection does. And that's how most of the way classic MVC works, right? Like you have a sort of route table, and you're saying adding a route, adding a route, adding a route. That's all based on this route collection. in routing, you typically think of routing as those templates, right, where you have these curly braces and there's values that get pattern matched to the request URI and data gets extracted from the URI in a nice route data collection. Well, where's all of that? That's in the route class. The route class is also an iRouter, and it's what implements the template route notion in ASP.NET Core. It's what knows how to parse those really cool template strings and deal with default values and optionality and constraints and all that jazz, and can match a request based off that logic. It does something a little bit extra though. When it matches the request, the way it matches is that you have to give the route another iRouter, and it will call that next iRouter. That's how it works. The template route implementation, you give it another iRouter, and if it matches, it'll call that iRouter. And then there's a route builder that you use to build up your route collection. And what the route builder, all it really adds is it has a notion of a default route, a default handler. And when you add routes using the route builder, it gives you a nice extension method that will add a route implementation, that route class, the template route class. But it will specify that the thing that it should route to when it matches is this default route handler that's on the route builder. And then with the route builder then, you just call build. It gives you the route collection. You hand that to the route middleware, and that's how it flows. Well, I'll try and show you a little bit. I know that's a lot to follow, but that's how routing works. And is the basis for MVC, because the way MVC then just works is MVC has a iRouter implementation that it sets up as the default handler on the route builder. And then you add your routes to it, and MVC is the route handler for all of them. And if any of them match, then MVC then gets invoked. Let's take a look. Oh, by the way, the whole system supports link generation 2. I'm not going to talk at all about that at all. I'm just going to talk about the one side of the flow. But there's also a whole other part of the stack that will generate URIs for you. The inverse, like how do you get the URI that would have gotten you there, that type of stuff. All right, let's look at it. Routing. I think I have a project for this one. All right. Okay, let's see what we got here. All right, I heard already started doing this. I'm gonna erase all this. Don't look, don't look. So down below I have my notes just in case I get lost. All right, so to use routing, you do need a new package. So I've already added it. This is the ASP.NET Core routing package. Ooh, and I've only got like 5 minutes. Okay, so I added the service, and actually because of the interest of time, I am going to actually show you this code because I don't want to miss out on one of the other two cool demos I want to show you. Okay. So first of all, here's the route middleware. Use router is how you set up the route middleware. And the simplest thing you could do is you could say new route handler, which is just an iRouter implementation that you give a request delegate to. You've all seen this code before, right? Response.write async. Hello from routing. Did I do that right? Missing one. All right, so all that, like actually I should show you. I told you I would show you the code. I will show it to you. This is the routing repo, and if we go looking in here for the routing middleware, is it? Or is it route middleware? Router middleware. There it is. It looks familiar, right? Like, so it's just a middleware class. There's the constructor that takes the next delegate. Here's the invoke method. Creates a context object, and it takes an iRouter. And the iRouter just has basically route async method on it. So it does add the router to this routers collection on route data. That's basically just keeping track of which routers ran that got you to the wherever you're at. It's sort of like keeping a history of which routers matched, because they kind of chain to each other. But it all it does is calls the router, route async. If the router put a handler, a request delegate on the context, then, well, it's down here, I guess, then it just calls the handler. If it didn't put a handler on there, then it just calls next. And that's the whole routing middleware. I was floored when I looked at this code. I was like, wow, that's so simple. So this should just say hello from routing. Yep, okay, so that worked. All right, and let's put it back the way it was, where we had some routes. Okay, and now let's actually create like a route builder and do some things that are interesting. First of all, let's get rid of this for now. Let's make things easy. Ignore this map route call. So now I'm going to use the route builder. I'm just going to set up like 3 or 4 routes that basically say, if you match this pattern, then execute this request delegate. So there's a simple way to do that. You can say route builder, and there's these map, get, post, put, delete methods that you can just use. It's sort of like if you've ever done node development, then people always show you like you set up a couple simple routes with a method, and you just execute some logic. That's basically this is the moral equivalent of that code. So we have a map get to time, random, and hello with a parameter. They do the obvious thing. Time will give you the current time. Random does a random number. Hello will give you a message that says hello, whatever name you specified. And then you build the route builder, which gives you a route collection, and then you give that to the iRouter, and the iRouter give that to the routing middleware, which will just iterate through those routes. So now if I run this, so what was it? Time, yeah, okay, so that's working. Random. So this each time I'm sending one of these requests, it's just getting routed to the corresponding request delegate that's right there in line in these extension calls. And then what was it? Hello. And then I have to give some name. I'll give VS Live, hello VS Live. All right. Last piece is, the way you normally add routes in MVC is you do this map route call, right? Now, if I run this right now, it won't work. It'll actually complain and say, well, you called map route, but you didn't specify a default handler on your route builder, and I didn't. The way map route works is it will create a route instance, but it needs a default route implementation to map each of those map route calls to. So I can do that through the route builder. There's a property, or I can do it in the constructor. Let me add back my default route handler. In this case, I'm just putting another one of those, that simple iRouter implementation that just takes the request delegate and always executes it, basically. And that should be sufficient. So now you can see what this, what my default route handler does is it just queries into the context to get the route data out for what matched, and then prints out all of the, the normal MVC parameters. So let's run that. Oh, what was the URL? I don't remember. Oh, it's controller action ID. So I need what, like home index 1, 2, 3, and there it is. Okay. So now to get to MVC, all you need is the MVC route handler right there, and that's how that works. I know I'm over time. I'm gonna go a couple more minutes just to show the last bit. It's not an hour. Oh, thank you. Oh, heck, I'll slow down then. I've got plenty of time. No, it's good. Oh, that's wonderful news. Okay, so the last 2 pieces. So we went through routing. We saw. Let me just show that really is the way MVC works. So, because I think that's useful. Well, if we go here and we look at the application builder extensions. All right, so here's use MVC, right? This is how you normally wire up MVC in an ASP.NET Core app. If we look at the, the real use MVC implementation, it takes the app builder, that's fine, and then it takes an action that allows the user to put their routes on the route builder, right? It takes an action of iRoute builder, and then it just makes sure those parameters are there. It makes sure that the MVC services have been added. It's just looking for a marker service. That's fine. It's just some validation logic. And then, lo and behold, here, we create a route builder. It specifies the default handler as MVC, the MVC route handler. It then calls the user's logic so the user can add their routes to that route builder. It adds a special route at the beginning. I'm not going to talk about this, but this special route at the beginning is the attribute routing system. It's a whole other topic, but there's one route that MVC will always add for you, which is the stuff that handles all the attribute routes on your controllers. And then it calls routes.build, gets a route collection, use router. That's all MVC is a system sitting on top of routing. Okay. Let's get into MVC now. Application parts. So there's a couple really nice extensibility systems in extensibility models in MVC that you can use to do some pretty cool and powerful stuff. And they kind of layer on top of each other. So I'm going to talk about them both all at once and then show them in a couple samples. The first is this idea of application parts. And what are application parts? Often, well, first of all, with MVC, there's a lot of discovery logic in MVC, right? Like MVC, it goes and finds your controllers. It goes and figures out what your tag helpers are. It goes and figures out what your view components are. It figures out what assemblies it should reference when it's compiling your Razor views. And there's logic that it does. And sometimes you want to change that logic or have it discover more stuff than in other places. Like maybe you have controllers sitting in another assembly, and you want to load it dynamically and have those controllers get found. How do you do that? One of the principles we've tried to follow with ASP.NET Core MVC is to really enable you to configure the system instead of having to rip out and replace large chunks of it. You could do a lot of these scenarios with MVC 5, like the earlier incarnation of the MVC stack, but you typically ended up having to implement some part of the system that basically meant you were re-implementing a bunch of stuff that normally we would do for you. And we always would have this long history of bugs of people asking, hey, could you make that one method virtual for me? Or make that one class public for me? Because I'm trying to do this customization, but there's this one piece that you guys wrote that it's not currently exposed, so I can't use it. And I'm implementing this extensibility point that basically requires me to implement all that stuff. I only want to tweak one part of it. So we've tried really hard with ASP.NET Core MVC to make it so you can just configure the stuff that we give you without you having to rewrite it all from scratch. Application parts is part of that, and the discovery logic in particular. So there's no like controller factory notion that you go and rip out and replace. This is the model that you would use to customize how controllers are discovered. Application parts you can think of them as resources where stuff can be found from. Typically, they're going to be assemblies, but they don't have to be. They could be something else. We do provide an application part implementation that's just an assembly that you say, I have another assembly I would like you to consider when discovering things. There's an application part manager that is really the one-stop shop for all of this discovery logic, and that's where you go and configure it to change how it discovers things. And the main things that it discovers right now are the 4 that I mentioned: controllers, view components, tag helpers, and the metadata references that are used for Razor compilation. Feature providers are then components that look at the set of application parts and figure out what features are there and add them to the system. So for example, there's a controller feature provider that we provide in the system that knows how to look at all the application parts, which are typically assemblies. It extracts all the types from those application parts and runs our normal logic for deciding if there are controllers or not. Does it end in a controller suffix, or does it have the controller attribute, all that jazz. But you can implement your own feature provider that adds controllers to the controller feature collection. And that's one of the things I'm going to show you now. You could implement other feature providers for the other parts of the system as well, tag helpers and view components and so forth. But before I do that, I'm going to talk about the second part of it, which is the application model. So application parts and feature providers are all about discovery and customizing discovery. Application model defines the conventions that we use to decide, what is an action in this system? What are the parameters of this action? What are its routes? That is all decided by the application model. And what it gives you is an in-memory representation of the entire app. You get this thing, this application model thing that says you have all these controllers, and these are the actions on the controllers, these are their parameters, this is what attribute routes they have on them. Feel free to look at it. Feel free to generate metadata from it, like a Swagger document, or generate clients from it if you want to do like client generation. And feel free to manipulate it, to modify it, to set up new conventions for what it means to be an action in MVC. Like maybe you want that if a controller is living in a particular namespace, that actually change the route of the controller. Or maybe you really liked some of the conventions that we had in ASP.NET Web API. Like in ASP.NET Web API, one of the things we had was if the method name for your action began with an HTTP verb, that implied that, oh, this is a get action or this is a post action. ASP.NET Core MVC doesn't do that because we had lots of debates about whether a postman action should really be a post or not. But if you like that model, this is a really simple way to re-enable it. And in fact, we ship a package called the Web API Compat Shim package. And what the package was intended to do was if you had a lot of Web API code that you wanted to port to ASP.NET Core, but you didn't want to completely move all the way over to the vanilla ASP core MVC model. You wanted to just move it as quickly as possible. This compat shim took the conventions that are normally there in ASP core MVC and replaced them with the Web API ones, using this model, the application model, to tweak what it means to be in action, what its attribute routes are. So that's actually how it's implemented, is using this application model conventions extensibility point. And like I said, you can also use the application model to explore your app. If you're familiar with the API Explorer notion from Web API, this gives you very similar functionality. And actually, the way Swagger documents get generated by like the Swashbuckle package is done through this model as well. Okay, let's look at it.
Quick question.
Yes.
So is it basically that the application part manager builds up an application model?
The application part manager is all about discovery. It's all about figuring out, what resources determine what's available in the system, and allowing feature providers to look at those resources and decide, yep, there's these controllers in this part, and there's these controllers in that part. So you can do things like dynamically load an assembly and find controllers from it. The application model is just giving you an in-memory representation of your app that you can look at and manipulate. So yeah, I've got all these controllers now that were discovered, but I want to now tweak this controller to say, this controller name really should be this, or there should be routes on these particular actions that actually map to these requests that normally wouldn't be there, but by convention, I would like them to be there, that type of stuff. I think it'll become clear also as I show you this example. So in this example, what it tries to do is have a notion of a generic controller, kind of like a fallback controller. Oops, back this one. And so the idea is that there's the normal controller discovery path where you look for a controller with the the name and the action with the name. But if there isn't a controller there, what this app tries to do is fall back to a generic controller that exists as long as an entity type, a model type, was defined that matches the name of the request path. So you see here that there's a home controller, there's a sprockets controller, and then there's a couple model types. There's a sprocket. There's also a widget, but there's no widget controller. The home controller, if we look at what it's doing, it's iterating over all the action descriptions and just displaying them. So it's just telling me what are all the actions in this system. Let's see what it says. Okay, so it says there is a home controller index. Check, that's that guy. It says that there's a sprocket controller index. Yep, check, that's there. And it says there is a generic controller of T for widget. Where is that guy? Well, that is this controller. So this controller is an open generic controller, right? Which normally that would not get discovered. That's not something that MVC just would say, yeah, that's a controller. It would completely ignore it. But what we do is we implement a feature provider, an application feature provider for the controller feature. Excuse me. And what this implementation does is it looks at the entity types that were defined. And this is just a static class that lists some set of entity types. You could make this logic more interesting. But those two types are sprockets and widgets. And then it creates a type name based off of the entity name. And it checks to see, is there a controller that already maps to this entity? If there is, then don't do anything. But if there isn't, we're going to create a fallback controller for that entity. And it creates a new generic controller of T, where the T is the model type, and it adds that controller type to the feature. And that enables this open generic controller to be discovered by the system. So that's how that works. There's also another piece to this, though. Like if we just left it at that, the name of that generic controller of T would be like that, which like MVC by default would just uses the type name for the controller name. So when you were routing to it, you'd have to use generic controller backtick 1 bracket widget in order to route to it, which kind of stinks. We'd like the name of the controller to just be widget, and we can do that using the application model conventions. Remember, the conventions are all about what is the name of the controller? What are the filters in my system? What are the action names, the parameter names? What routes do they have? So here we implement an iController model convention, which gives me a model object, a representation of what this controller is. And I can look at it and I can manipulate it. So here it looks at the model type and checks, first of all, is this a generic controller? Yes, okay, it is. Good, then we're relevant. It grabs the first generic argument, and then it sets the controller name to be the name of that entity type. How do these things get configured? If we look at startup, so here when you're adding your MVC services, this is where you get to play with the application part manager, where you can add whatever feature providers you want. This is where I'm adding the generic controller feature provider, the thing that's going to discover that generic controller. This is also, by the way, where you would say, like, if I just want to add an application part, like a random assembly, you could do that here as well. And that would just make that assembly be considered for finding controllers and tag helpers and view components. And then the other piece of it was the convention, how that get applied. Well, the convention in this case is an attribute, and it's just getting applied directly to the controller. So there's where the convention is being applied. So the system will look at that controller and say, oh, there's an application model convention for this controller. Its name is not just the name of the type. It's the name actually of its generic parameter. So if we run this, if we run it, oh, it was already running, so that's fine. If we do, so that's home. If we do sprocket, so this is a non-generic sprocket controller. Remember, our discovery logic only kicks in if there isn't already a controller there to handle it. There's no widget controller, but if I type in widget here now, I now get that widget controller called from the system. One more quick example for the application model conventions. This example sets up that namespace convention, where I want the routes for my controller actions to be derived from the namespace that the controller lives in. I don't think you'd ever should do this, but this just shows what's possible. So in this case, I have a user controller living in an admin folder, and then I have it lives in the my site admin namespace, and then the products controller lives in this my site inventory namespace. And then there's a namespace routing convention. In this case, this is not a controller model convention. This is an application model convention. This guy doesn't just get access to a controller model. It gets access to the full app, and it can do whatever it wants. So it goes through all of the controllers. It finds out their namespaces, and then adds attribute routes to all of their actions where the path is derived from that namespace. So now if I run this app, and again, the way that got configured in the system is just by the convention in this case gets added through the MVC options. You just add a convention, a top-level app model convention. Run this fellow, or lady, I'm not sure if apps have gender. So I think that was my site, inventory, get product details. That's the routing to the first controller. Now the second controller actually has an attribute route already on it. And if you look at the convention implementation, it actually checks to see, are there any attribute routes already on this controller? If there are, then don't touch it. The user probably was being explicit on purpose. So if we try to go to my site admin, that won't actually work. It won't actually be there. Instead, we have to actually go to the get user by name, and that will work. So that's just showing that the application model can honor overrides by existing attribute routes. That's what we got. Oh no, go back. All right. So that was all my set of demos. So we saw hosting, we saw routing, we saw hosting in IIS, and also the hosting at the process level. We saw how request handling works, how to write custom middleware, and we saw some of the cool extensibility points in MVC, how you can control discovery and also control the model for your application. I hope you enjoyed what you saw, and I'm happy to stick around to answer more questions, but thank you everyone for coming.